'cause I don't give a fuck what you say. Yeah, I'ma do shit my way.
Welcome to Chip Logic Studio, and in this video we will discuss about coverage in verification, and I will explain and show you the code of coverage. So be patient and understand whole concept, then we will go towards the code. So if you haven't subscribed my channel, so please subscribe my channel and press the bell icon. So coverage ensures verification completeness, means there should be something that we can tell that we have completely verified our design. So coverage plays that important part, helps measure what functionality has been tested. It helps that to how much cover we have covered our coverage, means functional coverage and code coverage. There are two parts. So we will go towards the types of coverage, but before that, essential in SystemVerilog verification methodology, means SystemVerilog and UVM methodology both has this coverage part, because it is important that how much coverage or how much functionality of our design as well as our test bench we have covered. So first is our code coverage. So basically code coverage is how much our code is covered, how much number of lines of our design code is covered, not test bench, only RTL code we are speaking here. And types of code coverage are statement coverage, means number of statements like conditional statements, if else, case, everything, that how much is covered. Like if you are writing if condition, then else condition should also be covered in some other test case. Branch coverage means similar, every branch should be covered, like case inside that there is every branch, everything. And expression coverage, like y equal to a plus b or something. Toggle coverage, for example, if you have declared a variable of 64 bit, so every bit should toggle of that. Automated by simulators, so code coverage you don't have to write, it is already covered in your simulator, and it show you a table after you have completed your whole simulation. But functional coverage is important, therefore it is called functional verification to a design verification or MS verification, because a design has some features and functionality. We are checking that all the functionality or all the features are covered or not. So user defined coverage to track design features. So we create design or functional coverage part in our test bench and implemented using cover group and cover point. These are the two keywords we will see afterwards in the code. Example: protocol, packets, types, corner cases. Yeah, all of the packets we send towards our design through our test case scenarios are then checked by our functional coverage that it is covered or not. Also, test bench meets verification goals. So some set of goals are there. For example, if the version 1.1 is there, so it said that 93% should be functionality should be covered, then next version should cover 97%. So target is also achieved with the functional coverage. Without any delay, we will go towards our code. So this is our UVM code, but similar code you can write in your SystemVerilog. So this video is same for Verilog as well as for SystemVerilog. Now functional coverage, you have extend your UVM component class, and you also register with your take UVM utils, and transaction should be need for taking our coverage, every coverage variable, because all the variables are in our transaction, and we send these transactions towards our duty, so we need that. And your UVM analysis port, we are getting some data from our packets, so we need our TLM ports. From monitor we are getting all the packets, and we will check that coverage. So here is your cover group, it's like your module and module for your coverage, and this is only thing which has end group, not end cover group. So keep remember this, that cover group and cover group is there, and you have declared a name CG for your cover group. And this is your cover point, you should give a name to a cover point. This is a simple syntax, that CP1 has your cover point keyword, that we are covering this point, which is our p adder. P adder is one variable inside your T1 packet, and in that p adder we are covering 0 to 30, means this bin is our vector bin which is having 0 to 30 as a range, and whenever there is 0 to 30, like 1 2 3 4 up till 30, up till all these numbers are coming in your packet, we will count that as a 1 in v1. So this is your bins, which is bins is like something which hits, and it will check that this part is covered, like 0 to 30 is covered, so you will get your some percentage of covered of 0 to 30, something like that. Ignore bins are like you have to ignore 31 to 256 as your numbers in your added p address. Your address should not cover 31 to 251. So this is your bin 2, and we will ignore these numbers, so it will not add in your percentage of coverage. Second, we write our cover point for our PW data, and similar for that also we are covering all our 0 to 30 and ignoring some of your values. We are ignoring that. Illegal bins are like it should not hit like 256 to 999 is not a number we with our range in PW data. It is up till 256 only, so illegal bin should hit, then it is some errors. So you also covered some illegal part. Our p select is having 0 and 1, so we will cover that. Now we have come to our transition bin. Like we are covering our states here, like b6 0 to 1 it should go, and 1 to 0 it should go. So we are checking our low to high point, that coverage we are covering here in p select. And p enable is also same as our p select as well as our other groups. So this is all about your cover points and coverage. So in cover group we will write a name for cover group and a name for a cover point, and just select a packet dot our p address, and we will cover all the bins. And there are number of bins. Transition bins are also there, ignore bins, illegal bins. Keywords will change. You can understand the statement in any website or something, and the simple concept is that you have to give some range for that, and it will show you some data in your terminal, or if you are using Cadence or Synopsys, still it will give a proper format for how much it is covering your coverage, some percentage about it in your terminal. So you can just take your cg.sample as a EDA playground has some syntax like cg.sample, and it will give your coverage. So I will once run this. If it is showing our, see here is your functional coverage 53. So we have only covered 53% of our coverage. That is our functional coverage.
And I don't really care what you think of me, respectfully. You can kick rocks if you think you're fucking better. See, I will outwork you.